Hallo, hallo, it's Dumplet here. Here's an item on geometry. So take a look at this figure. The two purple circles are tangent at this point. This blue segment is a common tangent to both circles. And we have two segments that intersect at the point of tangency of the two circles. This chord has length 6. Given these conditions, we're asked to find the measure of angle x. Credits to Jonathan Key for this wonderful item. As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. Alright, so here we have a lot of tangencies, and whenever we have tangencies, we have nice theorems related to that, maybe angles, maybe some properties of lengths, because we can get some lengths probably using the power theorems. So those are the potential starting points to this question. So since we're asked to get an angle, maybe we have to play around with the angles a bit. So let us try to make some observations on the angles. So I just connected these two. I just drew these two segments, the black segments, and this red segment I drew it because, well, that will serve as the common tangent at this point. So this red line is tangent to both circles at the point of tangency of these two purple circles. All right, and I'm going to mark this green angle. I'm going to mark this angle as green. So I can easily do my angle chasing. So let's try to make some observations here. Now, since this angle is x, so this angle is x, but we know this blue segment is a tangent, so we know that this angle, which intercepts this arc, right, that should equal to this angle, because this angle intercepts the same arc. So that's 1. Now, by the same reasoning, we can say that this must also be the right angle, because this is technically also a tangent intercepting the same arc. Alright, now here we have vertical angles, this one and this one, so we can put this one as red as well. And now this angle intercepts this arc now, because this red line is a tangent, so it intercepts this arc, so it must be equal to this angle over here, because this angle, this inscribed angle, intercepts the same arc. Right, with this actually you can kind of see that this and this angle are the same, and in effect, although it doesn't really seem to be like that in the figure, but we can have these two alternate interior angles to be congruent. Therefore, we can say that these two lines are going to be parallel. Although it doesn't look like it, we have proven it to be parallel, like right now, because of the fact that these two angles are both red, so they are congruent. Okay, now you can actually get this result. It's actually a direct result of Reims theorem, so you guys can look it up. It's a direct application of the Reims theorem, so you guys can use this is trivial by the Reims theorem. So, but anyways, this is technically just angle chasing, and the proof for Reims theorem is also just angle chasing anyways. Alright, so moving on, let's try to deal with this green angle. We can do some similar logic here. This green arc is intercepted by this green angle. So by the same reasoning, we can get this angle to be green. And same again, this angle would also be green because, well, it is tangent intercepting the same arc. Same reasoning, we're going to use the vertical angles here. And then by the same reasoning, alright, this green angle here intercepts this arc. So this angle must be green. Alright, now let's take a look at what's interesting here. And what's interesting is this triangle that you see above. Right, that triangle is pretty interesting because if you take a look at the angles inside, it's this red angle, it's this green angle, and the other angle is also red plus green. So this entire angle is also red plus green. Now, what does this tell us though? So let's just call this angle to be y for good measure. So focusing on the triangle here, we're going to get that the sum of the angles is going to be x plus y plus x plus y. So this is going to give us x plus y plus x plus y. That's going to be equal to 180. Now that's just simply equal to 2 times x of x plus y. So with this, I can actually get that x plus y. It just has to be half of 180. So it's going to be 90 degrees. Now, x plus y being 90 degrees, it's a very simple proof now that this angle is going to be right. And with this angle right, we can actually use it. We can actually use a lot of nice things because, well, if we have this angle to be right now, we can actually do some triangle similarities because this angle being right has a lot of implications. Let's go back actually. We found out that this angle is also green and this angle is red. So, right, this angle is red and then this angle is green. So, well, we know that red plus green, x plus y a while ago, that's 90 degrees. So this is going to be a right angle as well. Now, we're going to have some similarities here. We realize that this triangle ABD is similar to triangle ABC, as you can see here. So we would be able to form some nice ratios. So let's try to build some ratios here. So in triangle ABD, I know that A over B, all right, A over B, it's technically the longer leg to the shorter leg. That should be equal to, let's use triangle ACD, right? Longer leg is 6, shorter leg is A. So A over B, longer leg to shorter leg in triangle ABD should be equal to 6 over A. Longer leg is to shorter leg of triangle ACD. Right, that's the first ratio. That's the first equation that we can form. The next one, let me try to use ABD first. So I'll write B over 4. So that's going to be shorter leg to the hypotenuse of the right triangle. So shorter leg is to hypotenuse. That should be equal to shorter leg over hypotenuse. So let's try to use triangle ABC. So shorter leg is actually the 4 here. And then the hypotenuse here is going to be BC, which is B plus 6. Right, pretty interesting because, well, the second one gives us a value, the second one gives us a value of B because it's just an equation in terms of B. And once we have B, we should be able to get A using the first one. So let's try to do that. If I cross multiply here, I will get that B squared plus 6B. It's going to be equal to 16. So B squared plus 6B minus 16 is equal to 0. Let's try to factor this one. I'll get B plus 8 times B minus 2. That's going to be equal to 0. Now, that's going to give me negative 8 or 2 for B. But obviously, we're talking about lengths here, so we're going to ignore the negative 8 case. So I'll have here that B is equal to 2. So let's write that down. We have one solution, B is equal to 2. And now it's a matter of substituting the first one. So I'll have, let's try to cross multiply. We're going to get A squared. It's going to be equal to 6B. But we know what B is. B is going to be 2. So A squared here, it's going to be 12. Again, we can take the square root, only the positive one though, because we're talking about lengths here. So we're going to get that A is going to be equal to square root of 12. Now we can simplify this because 12 is 3 times 4. We can bring the 4 out. So square root of 12 becomes 2 square root of 3. So we have values for A and B. Let's plug it into the figure and we're going to notice something interesting because, well, right, this is the A, that's the 2 square root of 3. This is the B, that's the 2. But if we see, again, if we're going to focus on the top triangle here, which is a right triangle actually, the ratio of the sides, well, let's try to see 2 is to 2 square root of 3 is to 4. If I simplify this, we can divide everything by 2 here. We're going to get 1 is to square root of 3 is to 2. It's actually the ratio of sides in a 30, 60, 90 triangle. So we could have used a trigonometric approach, but the similarity just works fine. But with this, we would know that the angles of this right triangle are 30 degrees, 60 degrees, and 90 degrees. And these should be opposite the side length with that corresponds to ratio 1, square root of 3, and 2 respectively. So let's try to see angle x. Angle x is opposite of 2. Now 2 corresponds to the 1 in the right triangle, and we know it's the shortest, so it must opposite the the smallest angle. So with this, it's enough for us to conclude that angle x would be 30 degrees. And this will be our final answer. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye!